Electronics and Communication Engineering, GATE 2021. Consider the circuit shown in the figure. The value of V0 rounded off to one decimal place is dash volt. For a lecture on Kirchhoff's laws and concepts, please refer the NPTEL lecture, Lecture 3, KCL, KVL and Network Analysis by Professor S.C. Datta Roy, IIT Delhi. The Kirchhoff's current law states that the algebraic sum of all the currents entering and exiting a node must be equal to 0. Here we can see that we have 5 branches and there is one node connecting these 5 branches. The currents I1, I2, I3 are entering. The currents I4 and I5 are exiting. The algebraic sum of all these 5 currents is equal to 0. In other words, the currents I1 plus I2 plus I3 is equal to I4 plus I5. Let's make use of this basic concept to solve the problem. This is the circuit that is given to us. We have to find out the voltage V0, which is across the 1 kilo ohm resistor. We can use mesh and nodal analysis to solve this problem, but since this is a 1 mark question, we can quickly solve it by applying the principles of source transformation and by using Kirchhoff's current law. We see that this voltage source is in series with this resistor. So this can be combined by a current source in parallel with the resistor. The value of the current source will be 4 volt divided by 1 kilo ohm, which is 4 milliampere. So we have a 4 milliampere current source in parallel with 1 kilo ohm. Let's replace this branch. So now if we observe across these two terminals, we have two resistors. We have two 1 kilo ohm resistors. So the voltage across both of them is V0. Let's quickly apply Kirchhoff's laws and find out this voltage. So at Kirchhoff's current law in this node, we will be getting, if we observe this node, we have two incoming currents, 4 milliampere, 6 milliampere, and then we have 3 outgoing currents. One is through this branch, the second one is through this branch, and the third one is through this branch. This current is, let us say, IB. Let's first find out IB so that this will help us to apply Kirchhoff's laws in node A. Also for that, let us apply Kirchhoff's current law over this node. The incoming current is IB and the outgoing currents are 6 plus 2 milliampere, which is 8 milliampere. So IB is 8 milliampere. So coming back to this node, we have two incoming parts, which is 4 milliampere and then 6 milliampere. Then we have three outgoing currents. One is through this, the second one is through this, the third one is IB, which we found out to be 8 milliampere. Okay, so you will be getting 6 milliampere plus 4 milliampere is equal to V0 divided by 1 kilo ohm plus V0 divided by 1 kilo ohm plus 8 milliampere. So this implies 6 plus 4 is 10, 10 minus 8 is 2 milliampere. 2 milliampere will be 2 V0 divided by 1 kilo ohm. So this implies V0 is equal to 2 milliampere into 1 kilo ohm divided by 2. So V0 is equal to 1 volt. The answer is 1 volt. Thank you.